A Newfoundland fisherman hauls up his nets to find more than fish. He faces the lifeless eye of a giant squid, a creature once thought confined to legends and centuries-old specimens locked behind glass. For more than 140 years, verified strandings have shocked Atlantic coasts, but now these deep-sea titans are turning up in places no one expected. What is driving these encounters? Climate chaos or something no one has considered? To uncover the mystery behind North America's giant squid sightings, we have to begin where fact first shattered myth. Inside a climate-controlled archive at Memorial University, a curator unlocks a cabinet lined with glass jars and faded tags. Each vessel holds the legacy of a rare encounter. Giant squid remains preserved from a time when these creatures seemed more myth than animal. The oldest specimen in the collection dates to the winter of 1873, when Newfoundland's coastal villages braced for storms and fishermen hauled up more than cod. That year, a series of strandings stunned Conception Bay and Portugal Cove. Local men pulled in tentacles nearly 6 meters long, with bodies so fresh that brine was rushed in from nearby saltworks to slow decay. The news traveled quickly. Letters and telegrams crossed the Atlantic, catching the attention of Addison Verrill at Yale. Verrill's team requested samples, and soon portions of tentacle and beak arrived in New Haven, where they were measured, sketched, and cataloged. The preserved remains from that era, some still on display at the Yale Peabody Museum, gave science its first clear look at Architeuthis dux. Over the next several decades, reports ebbed and flowed. In the 1960s, a cluster of strandings brought renewed attention to Newfoundland's shores. Marine biologist Frederick Aldrich, then based at Memorial University, began offering small bounties for intact specimens. Between 1964 and 1966, at least 15 giant squid were documented along the coast. Aldrich's efforts filled the shelves of the Logie Bay Marine Sciences Lab, where 8 specimens were cataloged by 1971. These were not just relics for display. They became the basis for anatomical studies, fueling debates about the squid's true size, diet, and mysterious life cycle. Archival records from what was called the Golden Age of Discovery show a pattern. Most specimens came ashore during winter, often after storms or shifts in the Labrador Current. Newspapers from the time describe villagers gathering at the water's edge, some skeptical, others awestruck, as scientists arrived to collect samples. The excitement was always short-lived. Giant squid tissue breaks down in days, leaving only fragments for study. Yet the documentation was meticulous. Photographs, hand-drawn maps, and careful measurements, body lengths, arm spans, sucker rings, were all logged and sent to museums or university vaults. By the end of the 20th century, the frequency of strandings declined. The cod fishery that had once driven so much human activity, and by extension, so many squid discoveries, collapsed under a government moratorium in 1992. With fewer boats at sea, encounters became even rarer. Today, the physical evidence from those early decades remains crucial. The preserved specimens at Memorial University, the Yale Peabody Museum, and provincial archives in Newfoundland form a bridge between legend and biology. Each jar and tag is a reminder for all the stories and sightings. Direct contact with a giant squid in North American waters has always been an extraordinary event. Rare, unpredictable, and fleeting. On a gray morning in January 2012, a battered carcass washed onto a stony beach outside Bonavista, Newfoundland. Local authorities called in marine biologists who measured the mantle at 2.5 meters, nearly the length of a small car. The arms, still supple, stretched out across the tide line, their suckers rimmed with jagged chitin. Within hours, tissue samples were packed in ice and shipped to a lab. There, researchers traced the squid's last meals through stable isotope analysis, finding the chemical signatures of deep water fish and shrimp. The specimen provided a rare chance to study fresh anatomy, revealing details in the muscle fibers and eye structure that had eluded earlier generations of scientists. 8 years later, another giant squid surfaced on the rocky coast near Cape Race. This time, the carcass arrived with a digital footprint. Smartphone footage circulated online before the researchers even arrived. The 2020 specimens tissue, preserved in ethanol, is still under analysis, but early results point to a local North Atlantic lineage, suggesting these giants are not lone wanderers, but part of a hidden population that haunts the deep waters off Newfoundland. While the Atlantic continues to yield most of North America's confirmed encounters, the Pacific remains a place of rumor and fleeting glimpses. In 2005, a remote camera system in the Gulf of Mexico captured a shadowy figure drifting through the lights at 1,600 feet. The footage, brief and grainy, showed a large squid, tentatively identified as a giant, though never confirmed. The Monterey Bay Aquarium Research Institute, known for its deep-sea explorations, has logged thousands of hours with remotely operated vehicles, but their archives hold only brief encounters with jumbo squid, not true giants. For those who work the water, the mystery is personal. On a fog-bound night off the coast of British Columbia, a fisherman named Dave recalls his crew pulling up a trawl net heavy with unexpected weight. What they found inside was not a cod or halibut, but a twisted mass of arms and a single, staring eye the size of a grapefruit. The animal was already dead, battered by the net and the pressure change. Dave's account, like so many from the Pacific, remains unverified. No samples, no photographs, just a memory carried home to shore. Modern technology has changed the nature of these encounters. High-resolution tissue studies now reveal genetic fingerprints, linking recent strandings to historical specimens preserved in glass jars. The 2012 and 2020 carcasses, dissected in climate-controlled labs, offer a rare bridge between the past and the living ocean. Each new sample, whether pulled from the surf or glimpsed in the blue glow of a submersible, adds another fragment to the puzzle. The evidence record is thin, but growing, pushing scientists to ask whether these rare arrivals hint at a larger, unseen presence beneath the waves, or simply reflect the luck of being in the right place at the right time. Beneath the surface, giant squid live in a world almost entirely hidden from human eyes. Most spend their lives between 300 and 1,000 meters down, in cold, dark waters where sunlight barely penetrates. At these depths, pressure is immense, and temperatures rarely climb above single digits Celsius. The anatomy of Architeuthis ducks reflects these extremes. Their eyes, the largest of any animal on Earth, reaching up to 27 centimeters across, are built to capture the faintest traces of light. This adaptation allows them to spot prey or predators in near total darkness. where only flashes from bioluminescent creatures break the gloom. Adults are solitary hunters, rarely gathering in groups. Each squid ranges alone, using long arms and two specialized feeding tentacles to snatch fish and shrimp from the water column. The body is soft and flexible, shaped for drifting and sudden bursts of speed rather than endurance. Unlike their shallow water relatives, giant squid lack the pigment cells that power color changes, so camouflage is useless in the blackness of the deep. Instead, their pale, pinkish flesh is almost ghostly. Encounters with living specimens are so rare in part because of their habitat and also because of their fragility. When a giant squid dies, decomposition begins almost immediately. The tissues, made mostly of water and lacking the tough collagen of mammals or sharks, break down within hours. Carcasses that reach the surface are often battered, missing arms or tentacles, and quickly scavenged by birds and fish. Even in cold northern waters, a stranded squid may last only a day or two before it is reduced to fragments. These biological realities help explain why sightings are exceptional. The deep-sea home of the giant squid keeps them well out of reach, and their bodies leave little trace when they do appear. Each documented specimen is not just rare, it is fleeting. A brief window into a life spent almost entirely beyond human observation. In the deep layers of the North Pacific, a silent force began to reshape the ocean. Starting in late 2013, a vast marine heatwave, quickly dubbed the Blob, spread across millions of square kilometers, raising water temperatures by 2 to 4 degrees Celsius from the surface down to nearly 700 meters. Argo float data revealed that in the Blob's core, temperatures at 300 meters, once stable and cold, now hovered up to 2 degrees above normal. For creatures adapted to the deep's chill, this sudden warmth was no small discomfort. At the same time, another invisible change was underway. The Oxygen Minimum Zone, OMZ, a band of low oxygen water that snakes through the mid-depths, began to swell and rise. In the Northeast Pacific, the OMZ shoaled upward by as much as 35 meters over just a decade. Dissolved oxygen at 400 to 800 meters fell by up to 1% each year, compressing the habitable space for midwater animals into a thinner and thinner band. Giant squid, like many deep-sea hunters, are finely tuned to a narrow range of temperature and oxygen. Their preferred zone, between 300 and 1,000 meters, grew warmer and less breathable. As the Blob lingered through 2016 and returned in 2020, the squeeze on this twilight world intensified. Model projections from the National Oceanic and Atmospheric Administration and international teams suggest that by 2100, the core of the OMZ could rise another 200 meters, shrinking the safe haven for deep sea life even further. For the squid, the options are limited: descend into even less oxygen, or rise toward the surface, where warmer water and unfamiliar predators await. This environmental squeeze offers a plausible explanation for rare coastal sightings. When the deep becomes inhospitable, even a creature built for darkness may risk the shallows. The Blob's legacy and the ongoing expansion of the OMZ continue to push the boundaries of where ocean giants can survive and where humans might encounter them. Naval sonar drills have long raised alarms for their impact on marine life. In 2000, a mass stranding of beaked whales in the Bahamas coincided with U.S. Navy exercises using low-frequency active sonar. Necropsies revealed inner ear damage, a pattern echoed in similar incidents from the Canary Islands to North Carolina. The link between sonar and whale strandings is now widely accepted, with several governments imposing restrictions near sensitive habitats. Yet, when it comes to giant squid, the evidence grows thin. One of the few documented cephalopod strandings tied to acoustic activity occurred in Spain in the early 2000s, where a cluster of dead squid washed ashore following seismic surveys. But these were smaller, shallow water species, and no confirmed cases have implicated sonar in the stranding of Architeuthis ducks along North American coasts. Despite years of naval activity off Newfoundland and the Pacific Northwest, incident logs and fisheries by catch reports show no clear spike in giant squid encounters linked to military operations. Deep-sea mining presents another frontier. The Clarion-Clipperton Zone, a vast stretch of the Central Pacific, has become a testing ground for extracting polymetallic nodules. Maps of mining licenses show a checkerboard of claims, mostly by European and Asian companies, hundreds of miles from North American waters. So far, commercial extraction remains stalled by international debate and a temporary moratorium enforced by the International Seabed Authority. Environmental impact studies warn of sediment plumes and noise, but the nearest mining activities lie far from where North American giant squid are found. No fisheries data or observer logs report increased squid bycatch near exploratory mining sites between 2016 and 2025. In both cases, sonar and mining, the mechanisms are plausible in theory, but unproven in practice for giant squid. The best documented impacts fall on whales and shallow water cephalopods, not on Architeuthis. For now, the record is marked by caution and unanswered questions, leaving the debate open for those who study the deep. Remotely operated vehicles first began probing the ocean's twilight zone in the late 1980s, their cameras trailing cables down hundreds of meters to places sunlight cannot reach. By the early 2000s, research organizations like the Monterey Bay Aquarium Research Institute had logged thousands of hours underwater, capturing brief encounters with deep sea life that would have gone unnoticed by earlier generations. The arrival of affordable, remotely operated vehicles and autonomous cameras transformed the search for elusive animals, including the giant squid. What once required a trawler and a lucky storm now sometimes comes down to the sweep of a lens in the right patch of water. At the same time, the rise of smartphones and social media meant that every beachcomber or fisherman with a camera could instantly share what they found. In the 2010s, the number of documented strandings and unusual marine encounters rose, not because the animals themselves had changed, but because the eyes watching the ocean had multiplied. Citizen science platforms began collecting reports from across North America, archiving photos and locations that once would have faded into rumor. Yet, the historical record tells a different story. In the 1870s and again in the mid-20th century, clusters of giant squid strandings in Newfoundland tracked closely with the intensity of the cod fishery. When fleets were busiest, more squid were reported, suggesting that effort, not abundance, shaped the data. After the 1992 cod moratorium, with far fewer boats at sea, sightings dropped, even as new technology made documentation easier. Today's datasets, built from a mix of remotely operated vehicle footage, smartphone videos, and scattered logbooks, reflect not only the hidden lives of deep-sea giants, but also the changing ways humans look for them. Conflicting theories now divide the scientists who study giant squid. Dr. Kat Bolstad, a cephalopod biologist from Auckland University, points to the role of detection bias. She argues that the rise in sightings is not a sign of a population boom, but a product of better technology and more eyes on the water. Remotely operated vehicles, smartphone cameras, and citizen science platforms have multiplied the ways people can document rare events. In her view, the data reflects changing observation patterns, not a sudden emergence of squid from the depths. Across the Pacific, Dr. Steve O'Shea takes a different stance. He suggests that short-lived, fast-growing squid populations are prone to sudden pulses, brief periods when numbers spike, driven by environmental shifts or food surges. O'Shea sees the scattered strandings and bycatch reports as evidence of a real, if sporadic, increase in abundance. He points to the Newfoundland clusters in the 1960s and the mass strandings in Japan as examples of how cephalopod populations can explode and vanish within a few years. For him, the question is not whether the squid are there, but why they appear when they do. Dr. Jyotika Vermani, executive director at Schmidt Ocean Institute, believes the debate itself points to a deeper mystery. She calls for a new generation of deep-sea expeditions, equipped with long-duration cameras and environmental sensors, to move beyond anecdote and bias. Vermani argues that only direct observation, hours of footage from the right depths, can resolve whether these giants are truly becoming more common, or if the ocean is simply revealing what was always hidden. Until then, the evidence remains tantalizing and incomplete, leaving the mystery of North America's giant squid unresolved. Giant squid remain elusive, their rare appearances reminding us how little we grasp of the deep ocean's boundaries. As technology sharpens our gaze, and climate shifts reshape marine life, what surfaces is not just a creature, it's a signal. Today, the true mystery is how much of our planet's future still hides beneath the waves. What do you think we will discover next? Share your thoughts below.